that's the question of the day. I'm Professor Q, so glad to be with you. Of course, I have my guest speaker here today as well. Hi, Rocky, how you doing today? Excellent, all right. So we are here to be able to talk about, can you guess? Maybe so, land and water. So my question to you is, how much of Earth, as we see here, is made up of land? And even more so though, what type of landforms are there? Go ahead and write that in your book right now. Okay, so what did you think? How much of land makes up here on Earth? Well, we know that 70% of this is ocean, so therefore the remainder would be 30%. You're right. But even more so is, what type of landforms do we find here on the Earth? Well, let's have some conversations just in a moment. But I'd like for us to look a little bit here at A, B, C, and D, as you can identify that each one of these have a very distinctive view. Take a look at A, B, C, and D. Okay, so what I'd like for you to think about is what caused these different types of landforms to happen. So write that in your book as well. Okay, so what type of landforms are out there on this Earth's surface? Did you say mountain, plateaus, plains, and hills? You're correct. Well, how are they formed? And what causes that to occur? So I'd like for you to take a look here at our simulated landform at this time and observe, of course, it's fairly a flat surface overall, but I'd like for you to make a prediction. What do you think will happen to this landform when I actually take this plate and move it into that direction? Once again, what will happen when I move this plate, this part right here, towards that direction? Go ahead and make the prediction now. Okay, well, shall we try it? Sounds great. Here we go. Oh my goodness, what do you observe is happening? Whoa, look at that. What happened to the surface of this landform? Oh, wow. Did you say that it actually was elevated? You're right. So at this time, please go ahead and quickly illustrate what this looks like in your journal. All right, so now I have another prediction for you to make. What do you think would happen to this particular landform when I take the same plate and move it towards me? Go ahead and make that prediction now in your journal, please. All right, are you ready? Here we go. Ooh, look at that land go. Oh my goodness. Please go ahead and illustrate what you see, what you observe. And the question is, did it match what your prediction was? All right. Wow, we are cooking with Petrol, aren't we? So what is Petrol? Actually, it's a short acronym for that of petroleum. And if you remember in our last video, we were also talking about natural resources, and petroleum is a natural resource. And so where do we find petroleum? In landforms, absolutely. So let's take a look, and my question to you is, make a prediction as what do you think will happen when I take this plate and move it at least about 1 inch away? Go ahead and make that illustration now. Oh, wow, are you ready? Okay, here we go. What did that make? Wow. Okay, Does this particular landform look like what your prediction is? Well, let's go over what we first did with your first prediction. That first prediction, when we put this plate towards, it actually created a mountain. Correct, because it got elevated. And then as we extended the plate towards me, it created a mountain range. Okay, and so then when I took this plate away from it, it created a valley. So this type of activity provides students the ability to see a mountain, a hill, and a valley. Well, I keep saying this word plate. Well, where am I getting this from? You're right, plate tectonics. And there's different types of plate tectonics, of course, but for our purposes, we need to understand for our students that we have plates. Now, take your two hands like your fists and put them together like a puzzle. And try to press with force as much as possible. And what happens is that you see there's pressure, and after pressure and pressure builds up, then eventually land will start to elevate and either slide over one another or other conduct types of events, like earthquakes and things of that. Oh my. But I don't want to be a spoiler alert, so let's look a little bit more then and reference how and what could possibly occur with I asked A, B, C, and D. Well, taking a look at A, we see that we do have an arch. B is a lot of definition within chipping away, particularly it looks like at those landforms, and many of those. C, we have big boulders, some that are somewhat smooth and others a bit rough. And then D is we have a nice, variations of landforms here as well. Well, what are two types of main forces that could actually help to be able to shape ABCD landforms as they are? Go ahead and write that down in your journal, please. So the different types of forces that act upon landforms is one is that of destructive and the other is constructive. So thinking of destructive means to destroy, to tear apart, tear down, whereas constructive is like a construction worker. It constructs, it builds up. So what types of Mother Nature forces or events then could be in each particular type of category? Well, I would like for you to think of is destructive. What events out there do we know of that tear things apart? At this time, I'd like for you in your journal, try to identify at least 2 destructive and 2 constructive events. So what did you predict? Well, let's talk about destructive, because that's where students really would have a better understanding or more prevalently seen. So as we see, a lot of what happens in California is like, whoa, earthquakes. And that's when, of course, the plate tectonics will shift and collide and sometimes pull apart. And then we have explosions of magma and molten, of course. Well, that's coming from volcanoes. Then we have something called floods. And here in Houston, we're very familiar with floods. Oh my. And so we have volcanoes, we have earthquakes, we have floods. And well, what about those landslides? Have you ever seen one of those? And what's even more prevalent, of course, is lately is sinkholes. Oh my goodness. When the earth just opens up and everything falls in. Those would be considered those of destructive forces. But what about constructive? Well, a lot of those, such as floods, can construct. They move things from one area to another to build up things. Earthquakes, potentially they can also construct too, where they build up land over time. But even more so, a big difference there is deposition. Say the word deposition. deposit is in that word deposition. And so students may think of, well, where have I deposited things before? Well, the bank. They take their money and deposit it in the bank. Well, the same thing can happen, whereas certain materials and sediments can be placed from one area and deposited into another larger area as well. One fine example of that would be in the Sahara Desert. Well, what do we find in the Sahara Desert? Sand dunes. And how did sand dunes get there? Well, sand dunes, through wind, will be pushed from one place to another. So, let's identify then, well, what are those three agents then that cause this type of landform to occur? Well, it goes under the umbrella of weathering and erosion. Say weathering and erosion. So the question is, what is weathering? Well, you've heard, of course, weather. Weather occurs on a daily basis. We never know if it's going to be raining, sunny, snowing, sleet, or hail. Who knows, oh my? But there's three major components of agents that help to be able to weather landforms. Can you guess what it is? Well, there is water, wind, and ice. Oh my. Say water, wind, and ice. Oh my. That's correct. Well, how does water weather landforms? Consistently beating that particular landform over many, many times. Well, what type of water are we talking about? It could be floods, or it could be snow, it could sleet, it could hail, or it could precipitate, as we would call it. So that is what may occur. Think of, well, what formed the Grand Canyon? That's a good question. And then we have wind. Well, wind can be strong. Have you ever been in a strong wind that sometimes you get a little bit off balance? Hurricane force winds actually make a huge impact on those landforms and cause sediments to break off and move along. Think about also wind such as the Great Sphinx in Egypt. Whatever happened to his nose? Did someone go up there and just go, I'm going to chisel that off? No, they didn't. It's actually an agent of Mother Nature called wind. And then last we have is ice. Well, how could ice, oh my goodness, change a landform? Well, we have water that then freezes, and that water could actually get into the rocks, and when it freezes, it can break those rocks apart. And that is called mechanical weathering. So we have water, wind, and ice, oh my. But then, well, what about erosion? Well, erosion is the movement of sediments. So I want us to take a step back here and take a look at this simulated rock. This rock is very large. So what do you think would happen as over time, if this hammer were wind, would continuously beat down or be weathered? Well, eventually it would look potentially from this section here of the rocks, and over time it would transcend to all of these smaller rocks here, which we can call sediments. So this is a very smooth rock, but was it always smooth? Not quite. Take a look. Oh my. Well, this rock once all around looked like very rough. So what was it that caused this rock to be smooth? Correct. It's the weathering, the beating down of elements of water, wind, and potentially ice on this rock that helped to be able to make it smooth. So over time, it was broken down. So weathering is the breaking down of sediments. What is weathering? Breaking down of sediments. Let's say that. What is weathering? breaking down of sediments, correct. Now, with erosion, erosion is the fact that those sediments are taken and moved from one place to another. What is it? It's moved from one place to another, correct. So erosion is like the ocean. Why? Because it moves from one place to another. Okay, so it's good for us to observe our surroundings. Have you ever gone across a bridge and seen perhaps a river or a lake in your travels? Did you get to see what the embankment looks like? All the different types of layers where the trees are. Are any of those trees starting to fall over? And if so, why? What caused them? Weathering and erosion, correct. So let's go ahead at this time and we are going to create a simulation of weathering and erosion. So we have our landform at this particular point, and my question is to you is that I am going to simulate rain, and in one particular location, what do you think will happen to this landform? So in your journal, please go ahead and illustrate what you think this landform will look once this precipitation is poured in one particular location. All right, did you make your prediction? Wonderful. So observe very closely. Here we go. Oh my goodness, what is occurring? We have precipitation. Can you see at this point that you actually have the water that is starting to spread out? It's being absorbed, isn't it? And what's happening over in this particular area? It's trying to make its way, but look at what the land is reacting to at this point. Oh my. Well, if we can observe over in this particular area right here that the sediment is actually a little bit more finer than the remainder of it. And as I see that currently that we have the water still moving slowly throughout the land. But the land held the water, didn't it? So then, this time, please go ahead and illustrate what occurred and then make a prediction. What do you think would happen when we had double the amount of precipitation? Can you do me a favor? All right, so what do you think is going to occur when we have double the amount of precipitation on our land at this point? So far, as you see, it's pretty much been stabilized, hasn't it? Are you ready to go? Okay, let's observe. Once again, the water will be in the same location. Well, so far so good. Oh my goodness, but if you take a look over here, the water's starting to emerge. Oh, look at that occur. Oh my goodness. What do we have here? And that was just one. Do you see how there's actually these forms? And what do we call these forms? Isn't that wonderful? Look at how this particular area became a little bit more refined. However, we now have this branching off. We have another little smaller branches, a larger branch of a stream, and this. So we've actually created stream and through the precipitation. And as you notice that, just imagine, could it be that these A, B, C, and D were formed just as we simulated here? Well, what was the weathering? The weathering was precipitation. Well, what was the erosion? The erosion is actually sediment, because does this look exactly as how we started out? Absolutely not. We see that actually we have more so of a delta. Well, what is a delta? The delta is a deposition of land that has been moved by erosion. And so one way to simulate this is this could look like a sandy beach in the ocean. Isn't that amazing? So the real question is then, well, what do you think if we actually had boulders on the landform? What type of impact would that have? Well, I'd like for you to go ahead and make that prediction and think about what type of impact and who has the boulders. Well, let's talk a little bit about Hawaii. Perhaps the boulders are in Hawaii, and perhaps that they could be shuffled and transitioned and fall down. So how could that Hawaiian neighborhood be protected from boulders? Good question, isn't it? Inquiring minds want to know. And you can get a paint rolling pin as well. So it's fairly simple to do for a wonderful simulation about land and water. Excellent. So before we go though, one important question to you is, well, how do glaciers affect land? Glaciers are immense. Do you know how far a glacier moves each year? A little bit less than potentially 1 inch. Can you imagine that? Whoa! So, but glaciers are ice, and what they will do is that they will dig through the soil and create a U-shaped valley. What does a glacier create as it slowly moves through the land? Because the ice will melt and pick up the sediments with it, and it creates a what? A U-shaped land, a U-valley, absolutely. Who knew? So it's been so much fun having conversation with you today as Professor Q. And remember, stay strong. Good, better, best. Never let it rest till the good gets better and the better gets best. And don't forget to like, subscribe, and hit that notification bell. You can get a... Where am I starting off from?